Today, lesson 4.5, we're skipping over 4.4, don't worry about it. And today's warm-up is a review of the concepts we've been studying, these heavy algebra concepts we are trying to master in preparation for next year. So let's see how we're doing. Prime factorization for number 1. What did you get? Got 3 confident people right off the bat and a semi-confident person. We'll start with Cameron, DeAndre, and then David.
2 times 2 times 2 times 2 times 3 times x times y.
Okay.
2 times 2 times 2 times 2 times 3 times x times y.
So I think that was the same thing. What do you think, David?
2 times 2 times 2 times 2 times 2 times 3 times x times.
Very nicely done. That is what you should have had. What about number 2? What did you get? We'll start with Adriana, Stephen, and then we'll go to Alexis. Okay, what did you have, Stephen?
2 times 3 times 3 times 3 times w times w times z times z times z.
I think that was the same thing as hers. What do you think, Alexis?
2 times 3 times 3 times 4 times 4 times w times z times z.
Very nicely done. And so what you learned was to do this so that we could then do things like 3, 4, and 5. That was the real work. Let's see what you ended up with. What do we get for number 3? We'll start with George, Annie, and then Essence.
4 over 12 a to the second power.
Okay?
1 over 3 a to the second power.
So that's very different. What do you think?
0 over
Okay, so we got 3 different answers. Natalie, what do you think?
1 over 3 a to the second.
I think that's what Annie said. What do you think, Catalina?
1 over 3 a to the second power.
So now we seem to have more support for that, and that is the correct answer. Now, if you put 0 on top, you can go ahead and give yourself half. That's fine. You didn't know that when all of them are canceled out that it's supposed to be a 1, because I didn't talk about that yet, but I'm going to talk about it in a couple of minutes. Okay, but there is supposed to be a 1. What about number 4? What do we get as a result there? We'll start with Tatiana, and then we will go back to Cameron, and then to Angela.
2x to the third power over y.
Okay?
2x to the third power over y.
So you agree with her. What do you think, Angela?
2x to the third power over y.
So all 3 of you agree. That's good, because that's the answer. What about this nasty, incredibly advanced-looking expression here? What would we get for that? This time we'll start with DeAndre and go to Adriana, and then we'll come back to David.
AC to the second power, d to the second power of 1.
Okay, what'd you get?
AC to the second power d second power over y. Wait.
I think it was the same. I'm not 100% sure. David?
AC squared, d squared.
A, c squared, d squared. If you put it over 1, that's the same thing, so you can put it over 1. As your teacher last year used to put it, there's always a skinny little Ms. Cooper right there. But when you study algebra and when you work with algebra, you're supposed to know in your head that there's a skinny little Ms. Cooper or a number 1 right there, but we don't write it. You just know it, and everyone knows it. I know it, you know it. Anyone else who knows how to do this math also knows it. So you don't actually have to write it, okay? So I'm going to go over number 3 and why that's a 1 on top in a moment, but I want to answer any other questions. So don't worry about number 3, but anything on numbers 1, 2, 4, 5. Anything at all? All right, I'm going to go over number 3, but now let me survey the class. There were 5 questions. Give me a thumbs up if you got 80% or higher. Wow, a lot of you. Okay, fantastic job. All right, so let's talk about number 3. So here's what we break it down to. The top. Can someone give that to us? The top breaks down to what? Stephen, go ahead.
4 times A times A times A.
Okay, but the 4 gets split.
2 times 2.
Okay, so yeah, 2 times 2 times A times A times A. What about the bottom? What does the bottom break down into? Kiara?
2 times 2 times 3 times A times A times A times A.
Okay. The part that I didn't tell you, but if you think about what I just said here, that there's always a 1, is that 1 is always a factor. So in actuality, there is a times 1 here, and there is a times 1 here. So if we cancel things out, 2 cancels the 2, that 2 cancels that 2. A. Now, we could cancel the 1 and the 1, but then there'd be another 1 there. There is an infinite number of 1s being multiplied there. So it's not 0. It's not nothing left on top. There's actually a 1 on top. Okay? So it is hard to understand. It is not the greatest explanation, but that's the reality, is that when everything's canceled out, you still have a 1. Just like we still had a 1 here, even though the entire denominator got canceled out. It's the same thing. So we're allowed to write an expression like this. Have you ever seen an expression written like this? With a blank space above a denominator? Never seen that before, right? That's because it doesn't exist. So we always have a 1 on top, and in that case, you do have to write it, because we've never seen that before. You do have to write the 1. Okay? Any comments, questions, or concerns? Nothing at all? All right. So, as I stated during the warm-up, we've been working on high-level algebra concepts in preparation for next year. And we worked on some different types of expressions. One thing I did not emphasize as we were working was the exponents that were always there. We've actually been working with exponents for 2 lessons already, and today we're going to focus on them. We're going to identify a couple of rules about exponents that you can use to actually do things a little bit easier than you've been doing. Okay? So, first of all, you are going to learn the product of powers property. The product of powers property says that if you multiply powers with the same base, you may add their exponents. So, keywords. We're talking about multiplying powers. They must have the same base. If you're multiplying and they have the same base, then you add their exponents. Now let me pause here for a second. The name of the property is the product of powers property. That's letter P, letter P, letter P. That sounds a little confusing. Let me confuse you even further. Next year, if you turn your eyes and bodies this way on my wall of properties, here is the product of powers property. You're going to learn 2 other ones next year. The power of a power property. Letter P, letter P, letter P. And the power of a product property, letter P, letter P, letter P. They all have the word property in them. They all have the word power in them. And they all have the word product in them. They all sound the same. They all sound the same. And they all look very similar. But they're actually they're not totally different, but they're different ideas, and you actually have to know all 3 of them. Here's the goal this year. The goal this year is to understand this one property, the product of powers property. You don't have to worry about the other ones. But I want you leaving my class at the end of the year knowing this so well that next year, when your teacher throws the other 2 into the mix, it's not nearly that confusing. So the product of powers property says when you multiply powers, same base, you add their exponents. So let's look at y. First, let's start with something simple. X times 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 x. I would like us to write that expression in a fancier, more advanced way. How could I write? Savannah?
No. X to the power of 7.
X to the power of 7. Tristan, do you agree with that? So that would be x to the power of 7. Tristan, where did she get the 7 from? I don't see a 7 anywhere. So? Oh, there's 7 of them. Okay. So that's a definition of a power. The definition of using an exponent is that you take the number of times something is being multiplied by itself, and that is the number that goes in the exponent position. So that's just a review of what an exponent is. Now let's go to today's lesson, and let's go a step further. Now I would like to simplify x to the 4th times x to the 3rd. Based on this property, what should the result be? Tatiana? X to the power of 7 should be the result. But let's look at y. So I would like to first start with x to the 4th power, and this time I would like to go in the reverse of this. Instead of taking this and writing that, now I want to start with the exponent. I want to rewrite it so it looks like this. So what could I rewrite x to the 4th power as? Could someone help us do that? X to the, only two people can do that? Okay, George. Very good. So this would be rewritten as x times x times x times x. And I'm going to highlight that in yellow so that we kind of lump it all together. So I highlighted it in yellow here, and that's that. Now I would like to rewrite x to the 3rd, and I would like that to be rewritten right over here. What could I rewrite x to the 3rd as? Oh, now we're starting to catch on. Stephen? So this will be x times x times x. So this came over here. The only thing I didn't put in was this multiplication dot right there, but that's just a multiplication dot like that. And in fact, if you're paying attention, you've got 1, 2, 3, 4, 5, 6 multiplication dots. Now let's look at this as a whole. Does that look familiar? Does that look familiar? Tristan?
Yes.
Okay. Where have you seen it before?
First one.
Yeah. The first one right there at the top. X times x times x times x times x times x times x is the exact same thing that I have written right here. And what did it equal? X to the 7th. And so now we just proved, since this is equal to this, that when you have it written like this, you can skip over this and just write that. So that's the idea of the property, is it actually allows you to skip over something that you would have had to do unless you knew the property. So that's the key today. Does anyone have any questions about that? Go ahead, Tristan. Yes. Okay, so now we're going to do some rapid fire. So you're going to put your pencils down. We're going to do rapid fire. I'm going to make up stuff off the top of my head, and we're going to see who's catching on. Okay? So, We've got z to the third times z to the fifth. What will that simplify to? Nolly? That will be z to the eighth power. How'd you do that, Nolly? That's right. All right. What about c to the eighth times c to the second? What will that equal? Cameron?
C to the 10.
C to the 10th. What about x to the 12th times x to the 8th? What will that equal? Kiara? How'd you do that? X to the 20th. Okay. What about y to the negative second times y to the 6th? What would that become? Amani? Y to the 4th. David, do you agree with that? How'd you do that? Yeah. What's that? Oh, you think she's wrong? Okay, Amani, you still feel confident in yours? How'd you get 4? Yeah, negative 2 plus 6 is 4, so absolutely it equals y to the 4th. Okay? What about 9 times 6? What does that equal? Alexis? Are you sure? Anyone know why I just put that in there? Chelsea? Yeah. Because what happens is some strange things. And I've been teaching algebra and pre-algebra for a long time. And so when I start teaching this, students start adding everything. Anything that's multiplied, they go, oh, Mr. Gallard said if we're multiplying, we add. That is not what I'm saying at all. What I'm saying is that if we're multiplying powers, this only applies to powers, that have the same base, then you add. So we didn't get tricked, and that's good, and Chelsea caught on to why I put that in there. Let's do a couple more. What about s to the 40th times s to the 55th power? What will we get there? Oh, we got some people who can add quickly. Essence? S to the 95th power. Good. What if I had a to the 10th times b to the 5th? What would we get there? A to the 10th times b to the 5th. We'll end where we started. Nolly? Exactly, that's what I'm asking. What would that become?
Yeah, wouldn't it just be that?
Yes, you're right, and she didn't get tricked either. Because you cannot use this property unless the bases are the same. In all of these cases, same base, same base. Same base, same base, different base. Can't use this property, and in fact, you can't do anything. All I did when I wrote my solution is I took out the multiplication dot. Other than that, there's nothing you can do. Everything was the same base. Same base, same base, same base. Let's do, that's good. So I got all the points across. Does anyone have any questions about the rapid fire round? Tristan? Correct. 1 to any power is 1. Very good. All right, so now we're going to slow down a little bit. Now you're going to pick up your pencil. We're going to do a few formal examples leading us to the more complicated work of the day. So, The first two are sort of like the rapid fire round. So we're going to start out simple. Simplify 4 to the 7th times 4 to the 11th. What do we get? Boy, we had a lot more hands up before. I guess people are still writing. Adriana?
4 to the
Are you sure?
18th.
Yeah, you should be because it's 4 to the 18th power. Because it's the same base, we're multiplying, we add the exponents, there's nothing else to do. If you're really kooky, you can go ahead in your calculator and do 4 times 4 times 4 times 4 times 4 times 4 times 4, and keep going until you get the actual value, but that would be totally ridiculous and to defeat the purpose of today's lesson, which is to actually use powers. So, don't bother doing that. Part B. Now we have something a little bit different. What about this? What do you think the result will be, Annie? B to the 6th. What do you think, Stephen? B to the 7th. But I see 2, 4, so I add those together and I get B to the 6th. Where'd you get the 7th? Ah, yes, you didn't get tricked. Skinny little Miss Cooper's right there. And so, yes, that is a 1. If you think of it the long way, though, if you use what we did during the beginning, this is really 2 B's. This is 4 of them. And that's 1. 1, 2, 3, 4, 5, 6, 7. This is B to the 7th power. Does anyone have any questions about that? Okay, so no questions at all? So between the rapid fire round and these two examples, we have a good basic understanding of the property. Now let's use it at a higher level. Part C. This is the real work of the day. So go ahead and write down that question, but then you're going to put your pencils down for another minute while we take a little side trip. So now I'm going to come over here. You do not need to copy anything I write in green. You just need to pay attention and participate. 2 times 3 times 5 times 4. I would like you to mentally calculate that right now. Give me a thumbs up when you got it. All right, Cameron, what is it? I'm sorry? 26? Okay, Tatiana, what do you think it is? It's not 26? Essence, what do you think it is? 120? We seem to have some disagreement. Yeah, it's 120. 2 times 3 is 6, times 5 is 30, times 4 is 120. So Cameron is turning red and sheepishly hiding himself, realizing his simple mistake. But that's okay, he won't make that mistake again. Now, I'm going to do a different one. You're going to do it mentally. Give me a thumbs up when you got it, okay? Just watch. Do it mentally. Give me a thumbs up when you got it. Well, how could, so a lot of people put their thumbs up really quickly. I don't understand. So Essence, how you put your thumb up like right away? How'd you do that? So what is it? That's 120 also? Catalina, you agree? That's 120? And you did it really that fast? Okay, well, all right, let me try another one. Hold on. What if I did this? All right, Natalie, that fast? You were able to? So what is that? Sure? George, you agree?
Yes,
It's 120. How do you know?
because they're just the same numbers in different orders.
Okay. So you guys are claiming that if it's the same numbers, but I put them in a different order, that it's still going to come out to the same value. That's what Essence really articulated. So let me rewind for a second, and let me do it a different way and see if maybe I can get a different result. What if I take the 4 and I move it over here, and I move the multiplication dot? What will that equal? Savannah, what will that equal? That's going to equal 120 also? Give me a thumbs up if you agree with her that that's going to also equal 120. So it's the same value again, even though I moved the 4 all the way over there? Okay, let me try this then. Let me back up for a second. What if I take the 3 and I move it over here and I move these over here? What will that equal, Chelsea? 120 again? Even though I move the 3 over and I move the 5 and the 4 over, it's still the same value? So I could have this or this, and I get the same result. Oh. So watch this again, because this is an interesting tool I have here. I can rewind and fast forward. So I get the same result. So now we have, through experimentation, come up with a rule that when you are multiplying a bunch of things together, the order doesn't matter. You will get the same value. So now let's apply this at a higher level, and now you can pick your pencils back up, and let's do this. We're going to now do 2x squared times 7x to the 6, but you're going to start doing something right now that you're going to continue doing for the rest of the year. When I ask you to simplify something, you're going to rewrite anything that's being multiplied with multiplication dots in it. In fact, I said rewrite. I don't really mean that. When you write it down the first time, you should write it down like this. Because that makes a difference visually, and it makes a difference for your mind. Because even though I just wrote the exact same thing as what was here, putting those multiplication dots allows me to see this that I just illustrated. It allows me to see the fact that I can take the 7 and move it over here with the multiplication dot. Why is that beneficial? Why is moving it a bonus for me? What does that allow me to do, Nolly?
You can see like the like terms for when you multiply.
Yeah, be careful about the phrase like terms, because like terms actually mean something slightly different, but I get your point, which is now we can see that this number gets multiplied by that number, and then we can see that this x squared is going to get multiplied by the x to the 6th. And so now we can just do them separately. We can say to ourselves, 7 times 2 is what? Raise your hand.
14.
Kiara?
14.
14. And now, x squared times x to the 6th equals what? Tatiana? X to the 8th, because you just learned today, when you have powers with the same base, you add the exponents. And so that is simplified. Does anyone have any questions or comments on what we're doing? Okay, so checkpoint. Number 1, you got 2 questions. You got a minute and a half to execute them. David actually just sit behind you. And then Karen. Division. Got it. All right, part A, what'd you get? Got a lot of confident people. We'll start with Amani, DeAndre, and then Fancy. What'd you get? Okay, what'd you get, DeAndre?
X to the power 19.
X to the 19th power. You guys all agree that it is x to the 19th power. Very good. What about part B? What do we get there? We'll start with Natalie, Angela, and then Nolly. Okay? What do you think, Nolly? It is w to the 14th power. Give me a thumbs up if you got both of them correct. Wow, outstanding. Put your thumbs down. So we've got the basics down. Now we can elevate and work a little bit differently. So, dividing powers. Just copy down part A. Now, we just learned one property. We learned the product of powers property. Product means multiply. Where does dividing come from? Let me show you. It was actually in my lesson. I just decided to not include it. So there I have the quotient of powers property. But we don't need it. We are so smart and so good at what we are doing that we don't need it at all. In fact, we've been dividing for 3 days already. Let me show you. What does this bar mean? Can someone remind us? What does that bar mean, Tatiana? Yeah, what does this bar mean right here? Natalie? Division. You've been dividing. You've been dividing since 2 lessons ago. You just didn't realize it. What did I call it instead? I used a different word, Natalie. Simplifying was a word I used, you're right. But when we did the division, I actually used a different word. Tristan? Well, a fraction is also division, you're right. But I started using a different word a couple of lessons ago. Steven? Well, an expression is what we're looking at. So I'm talking about the division in particular. Tatiana? Well, splitting is not dividing. Splitting is just changing something into a multiplication problem. What was done down here? What was all of that? Tristan? There's no such thing as least common factor, actually. Kiara? Canceling. Canceling is dividing. That's what canceling is. I didn't use the word dividing, I used the word canceling, but now I'm telling you that they're the same thing. They are synonymous. So, we don't have to learn anything new. We just have to make sure we understand very clearly what is happening. So let's look at part A. This is what you were taught to do, split things up. So we could rewrite this as 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 5 times 5, that's 5 to the second power. And now cancel out 1 for 1. There's a 5 on the top, I can cancel 1 on the bottom. There's a 5 on the top, I can cancel 1 on the bottom. And now what do I have left? What do I have left? Savannah?
5 over 7. No.
5 to the 7th power. 5 to the 7th power is the result of simplifying this. But now watch how smart we can be. Let me rewind, but I want you to try and keep the picture in your head. I'm going to rewind and erase all of this, but I want you to try and keep the picture in your head. That picture right there. Try to keep it in your head. We know that this means that there are 9 5s across the top, and this means that there are 2 of them. These 2 are going to cancel out 2 of the ones on top. So these are going to disappear. Watch. Let me go forward again. What got canceled out? What totally disappeared? What totally disappeared? Only 2 people can see what totally disappeared? What totally disappeared, DeAndre?
The denominator.
The denominator totally disappeared. But I want you to notice that the denominator had the smaller exponent. The 2 canceled out 2 of the ones up there, and we have 7 left over. Can anyone see a connection between the result and these numbers? What's the connection? Essence? 9 minus 2 is 7. So now let's do this a different way. We still use canceling, but we do it more creatively, and we say, these 2 5s are going to disappear and cancel 2 of these. I'm not going to cancel the whole thing. I'm going to cancel the exponent, and I'm going to change it to the number left over. How many were left? 7. So that becomes 7. The denominator is now 1, and so all I have is 5 to the 7th power. So that is the technique that I'm going to encourage you to use. If you don't understand it, that's okay. You can just write out the whole thing. Does anyone have any questions about that? So now we're going to go to the higher level, and we're going to do part B. 4x to the 13th over 24x to the 9th. I'm going to start out by changing the question so that you can focus and start seeing things the way I think you should be able to see them. I told you that when you write it down, you should be putting multiplication dots in. So you should write that you should have written this. That's what you should have written. But now watch what we can do. Mentally, here is what you should do. Simplify that. How could we simplify that? Dave? How'd you get that? You're right. It's 1 over 6. Well, if you divide it by 6, then unfortunately you would get something totally different. And what is the greatest common factor? Yeah, the greatest common factor is 4. And what he did was he divided the top and the bottom by 4. The other way to do it is to split it, just like I taught. This is really 2 times 2. This is really 2 times 2 times 2 times 3. That cancels that, and you get 1 over 6. Either way, you get the same thing. Does anyone have any questions on how we simplified that? Sorry. Any questions? So now, let's put this back, and let's ignore the numbers for a moment. What if I asked you to just simplify x to the 13th power over x to the 9th power? what will the result be? Catalina?
X to the 4th power over 1.
That's right. Because these 9, the 9 is smaller than the 13. These 9 are going to completely cancel out, but it's going to cancel 9 of these, and there's going to be 4 left. And I love how she pointed out that there are 4 left on top. And she's right. There's a 1 on the bottom. Now, let's put it all together. You simplify the numbers, simplify the variables, and the end result is x to the 4th over 6. That is it. Comments, questions, concerns about that? All right. Part C, continue the same idea, slightly higher level. But now I'm not going to white anything out for you. Now you need to mentally focus or mentally white things out. So you should have written down this immediately. You shouldn't have written it down the way you see it. And now cancel. Here's what I did. I immediately changed the 14 into 2 times 7. And then I left the x to the 16. And the 6 I changed to 2 times 3. And I left the x to the 11th because I already know what to do with that. And now watch how easy this becomes once you write that. That 2 cancels that one. The 7's going to stay, the 3's going to stay. All 11 of these are going to cancel 11 of these, and there will be 5 left over. And so what is left? The 7 is left on the top. X to the 5th power is left on top. And on the bottom, I have a 3. And so that is simplified form of that expression. Does anyone have any questions about how we did that? No questions at all? No questions on any of these examples? All right, let's see how you do on your own. Checkpoint number 2. You have 2 questions. You got 2.5 minutes. Go ahead and begin. see how we did with this higher level material. Checkpoint number 2. What did you get for part A? So it was Annie, and then Adriana, and then Natalie. What did you get?
50z to the third power over 5.
Okay.
10z to the third power.
Okay, so we have a disagreement.
10z to the third power.
So you agree with Adriana. Anyone else want to chime in? George?
10z to the third power.
There seems to be more support for that. And the correct answer is 10z to the third power. If you put 10z to the third power over 1, that's the same thing. Annie, you missed the fact that 50 and 5 can still cancel each other out. Okay? Part B, what did we get? We'll start with Catalina, and then Chelsea, and then Fancy. Okay. So you agree.
Negative 12 to the fourth power.
Okay, so we have some disagreement. What do you think, Amani? So it seems to be overwhelmingly negative 3 to the fourth power. So I put this example in on purpose because it always trips up some of my students. In fact, the answer I get most frequently is 1 to the fourth power. Because for some reason, putting those parentheses and a negative number in there all of a sudden makes you think it's something totally different. It is no different than this. X to the 9th power over x to the 5th power will equal x to the 4th power. The key to understand is that the base is the same. In this case, the base is negative 3. If it's the same, you don't do anything with it. You just leave the base and you just take care of the exponents. So it won't make a difference if it's negative 100 to the 9th power over negative 100 to the 4th power, to the 5th power. It's going to be negative 100 to the 4th power. It doesn't matter what the base is as long as the base is the same. Does anyone have any comments, questions about that? Good, we seem to be doing extremely well. Draw a line across your paper. Your classwork is page 199. You're going to do numbers 47, 49, 51, 53, 55, and 57. Now, I have assigned you the hardest questions in the entire section. And they require you to take what you've learned and go one little step further. So you're going to actually have to use your brain and think through it. So you got 6 questions. You got about 10, we'll say about 12 minutes. Of course, if you have any questions, concerns, or issues, just raise your hand. I will come to you. All right. Pencils down, colored pens up, and let's see how we are doing. And remember that I gave you the highest level questions in the practice section. Let's see how we did. If you did okay, great. If you didn't do well, that's okay, because again, I gave you the highest level ones. Here we go. 47. 4m to the 5th, n to the 7th. 49. 2a to the 3rd, b to the 4th. 51. 7m to the 4th, n to the 5th over 3. 53. 7c to the 4th, d to the 5th over 6. 55. 3a to the 3rd over 7. 57 was probably the hardest one to figure out how to write your answer. Comes out to 0.4 w to the 10th. There were 6 questions. I feel strongly that if you got 4 out of 6 of these, which would be a 67%, I think that would be a great start. Because you're going to find that when you do your homework, that the homework's going to feel much easier than this because I gave you all the hard ones. Okay? Give me a thumbs up if you got 67% or better. Wow, that's pretty amazing. That's phenomenal. Put your thumbs down. Are there any comments or questions on any of these? Essence and then Tristan. Okay, that's an innocent mistake. That's no big deal. So did you end up with this with w to the 10th? Right, but you got the w to the 10th part, so then that's great. So then you clearly understood what to do. That alone tells me you completely understood. So don't worry about it, okay? Tristan and then Catalina. Well, that's actually the same thing. In fact, I'd say your answer might even be better. Yeah, 2/5 is the same thing as 0.4. Yeah, so that's outstanding, actually. Catalina.
I actually did for number 57 everything wrong, except the only thing I did wrong was the exponent.
You said you did everything wrong, but then you said you
No,
don't.
I did everything
Right.
right. Yeah.
Except for the variable part?
Yeah.
Okay, so let's just look at that real quick. It basically comes down to this. You've got 6 W's, you got 8 W's on top. How many total are there on top? 14. There's 4 of them on the bottom. So it's 14 on top, 4 of them on the bottom. 4 on the bottom are going to cancel out 4 of the ones on top. Another way to do it is this. Just cancel right from the beginning. You could cancel this with that. These 4 will cancel 4 of those, and there'll be 2 left. W to the 2nd times W to the 8th is W to the 10th. Okay? Make sense? Good. Draw a line across your paper. Your homework is page 199, numbers 24 through 58 even. And you're going to have a quiz on chapter 4. Today is Thursday.